So we continue the discussion where we stopped last time. So last time we were discussing how we can in general we have noted down that what is system. System is nothing but the manner in which the output is obtained by a weighted sum of current and past inputs. It can be passed few inputs, then it is very simple, but if it is passed all inputs, then it is an infinitely long sum, and to implement infinitely long sum it is impossible as we proceed because it takes longer time to compute. So we were talking about whether the infinite long sum can be expressed as a finite sum using iteration. So converting an infinite sum into a finite recursive sum or vice versa can be done. We did the first thing, that is converting infinite into finite. Now we are converting finite iterative sum into infinite sum, and that is the infinite sum which we got this. But here the problem is that the summation was 0 to k equal to 0 to infinity a raised to k by 2 x of n minus k e1. So when it is writing such k even here doesn't suit the purpose. So what we can do is can we make it a generic expression which should be true for every k. So in that case what we can do is, if there is a very simple what we can say expression using minus 1 raised to n or minus 1 raised to k. So if we can have 1 plus minus 1 raised to k, if you have got 1 plus minus 1 raised to k, if k is even, this expression becomes 2, and if k is odd, this expression becomes 0. So this is for even k. Even k, and this is for odd k. So in general, in this summation, below the summation sign, there should not be any condition. So what we want ultimately is this something should not be there. So can we make it some changes like this? So y is equal to, instead of this, that is this one, xn plus a xn minus. So what should happen is that the term should disappear. So somehow if we write like this, 1 plus minus 1 raised to k, then we will again say, is it permitted? Yes, it's permitted. This we can say it also. K equal to 0 to infinity, then a raised to k x of n minus k, and overall there will be half because it comes twice. So we can verify this. So whether you tell me whether this expression matches with this answer. So what will happen if k is 0? If k is 0, in that case this will become 1 plus 1, that is 2, and this half, that is 1, a raised to k, that is k is 0, so 1, so it is k is 0. So for k equal to 0, it will k equal to 0. For k equal to 1, what will happen? When k is equal to 1, this becomes 0, so whole becomes, for k equal to 1, term disappears, no term. For k equal to 2, we will find that it is this term. When k is equal to this again 2, half is 1, then only small problem is there. It is a raised to k, where k is 2, so you can have this as a by 2. Is it all right? A by 2 is not all right. A raised to, or we can write it as root a. Root a raised to k. Right? So this is the correct expression. So for k equal to 0, it is xn. For k equal to 1, term disappears. For k equal to 2, it is, this is 2, this is half, so product is 1. Root a raised to 2. Root a raised to 2, root a raised to 2 is A. So this is A. For k equal to 3, term disappears as this is 0. For k equal to 4, root a raised to 4 is a square. So this term, this is the finite recursive sum is converted into an infinite sum like this. So then you will say, again it is having the terms, but it's no problem. 1, so this you can separate also, half into bracket, summation k equal to 0 to infinity, one term you can have, root a raised to k x of n minus k, plus half summation minus root, this you can say plus root a, minus root a with minus 1 raised to k x of n minus k. So this is y. So both expressions are alright. So in general what we concluded is that we can convert any expression which is finite term recursive expression into an infinite term non-recursive expression. Into an infinite term non-recursive expression. So what is hk here? What is hk? This is hk. So ultimately we need to convert it into this form. So what we want is this one. Finally, it must be expressed as hk x of n minus k equal to 0 to infinity. That's all. So nothing should be there. So y should be equal to. So hk is this one, half. Where hk, this you can say that all this you can include, half you can take inside. So this half you can take inside, half 1 plus. So whole this would be hk, where hk is an expression of k, is half into bracket 1 plus minus 1 raised to k So this finite term recursive expression is converted into an infinite term non-recursive expression where hk is the transfer function, of the system. So in general, I again repeat that for discrete time systems, the things are so simple that input is a sequence, system is a sequence, and output is also a sequence. So entire discussion for major part of this subject and in this next semester for digital signal processing, everything is nothing but appropriate study and analysis of these sequences. So it becomes somewhat simpler. What I repeat is that the reason for beginning with the discrete things is somewhat easier. It doesn't mean that continuous things should be skipped, but it is better that we should start with some easy things so that some interest is created among the students about the subject. So now if you go to the syllabus, then there are many standard things with which some definitions and all these things are there, for we will define them one by one. So xn, hn you can write, no problem, and yn. Only thing is that while writing an expression where we are required to use both indexes, we treat as HK. But if you want don't want to be in a confused state, then you can say that yes, sequence is HK. So inputs, what is important is input sequence, system sequence and output sequence. Input sequence, system sequence and output sequence, and this what we write is called as convolution equation or convolution sum. K equal to 0 to infinity h of k x of n minus k. This is convolution sum. This is convolution sum. So how we carry out convolution? We write Hn. One sequence we write xn. So suppose if I write n equal to 0 here. So if Hn is 2, 3, 1 and xn is now 4, 5, 6, 7, 8 and so on. Now how to carry out convolution? How to carry out convolution? There is a very simple process. I would not like to spend time on repeating simple things. What is so yn is convolution. This is called as convolution, convol. To compute, the things are very simple. This can be infinite then. So you just flip around this, take mirror image around 0. So 2, 3 and 1. 2, 3 and 1. This is the simple way of explaining this convolution. Then one sequence xn, flip the sequence hn, you multiply point by point. So here multiplication is 8. Here there is no multiplication. So what is that? What happened now? This is starting point 0. So what has happened? Xn's are 0 before 0, and in the flip sequence all samples will be 0 here and 0 on this side. So because it is 0, 0, 0 and 0 onwards. So Hn is a 3-point sequence. Hn is a 3-point sequence which is having only non-zero terms for H0, H1, H2. H0, H1, H2 are the only non-zero terms. When you flip it, this 2, 3, 1 becomes 2, 3, 1, and then Xn we write as it is flip sequence. So to compute X0, to compute Y0, what we do? We perform sample to sample multiplication of these sequences. We perform sample to sample multiplication of Xn and flip the sequence Hn. So only one point is there, that is 8. Y0 is 8. Why? Because in other points, one of them is 0. Either Xn is 0 or flipped Hn is 0. So Y0 is 8. Then what do we do? Then to compute Y1, we shift this one location ahead. 2, 3, 1, 0, 0, 0, 0, 0, 0 onwards. So when we compute, so Y0 is 8 only. So here what we get? 3 into 4, 12. 2 into 5, 10. So 12 plus 10, so this is equal to 8. 12 plus 10, 22. Then to compute Y2, what do? We shift it once more. So when you shift it once more, it becomes 2, 3, 1, 0, 0, zeros. So in that case, this is 4 plus 15 plus 12. That is equal to 28. So like that, you can go on. So this is convolution of one sequence Hn, other sequence Xn. So now what is the scenario? Here Hn is 3-point sequence, and Xn is a continuous sequence now going till infinity. Suppose if Xn is also a finite sequence, if Xn is also a finite sequence, then suppose if Hn is equal to 1, 2, 3 and Xn is equal to 2, 3, 4, then what will happen? Compute y, which is convolution of hk x of n minus k equal to 0 to infinity. So in that case, what will happen? Again same thing, you can take only small change here. What will happen is that this would be again repeat, this is some very simple thing. I am just giving one example. It is, I think, middle school scholarship level problem of finding out convolution of sequences. So Xn, that is 2, 3, 4, Hn is 1, 2, 3, you flip it. So flip is 1, 2, 3 and then you take product, flipped 1. So 2 into 1 is 1, that is y0. For y1, what do? You shift it here, 1, 2, 3, product is this into this, 4, 1 and the answer is 1, no, there is no point other. See, for compute y0, what we do? Xn we take as it is, Hn we mirror image and multiply point by point. So 2 into 1. In other cases, there is no multiple point, this is 0 and here this is 0. So 2 into 1, I am sorry, this term is 2, so answer is 2. Now we shift Hn by one more. So this is Xn, this is Hn, Hn, mirror image Hn, shifted Hn. So mirror image Hn we get y0 term. Shifted Hn by 1 we get 1 into 2, sorry, 2 into 2, 4, 3 into 1, 3, it is 7, other term 0. For y2, we shifted once more. So when we shifted once more, it becomes 1, 2, 3. So it is 3 into 2, 6, plus 2 into 3, 6, plus 1 into 4, 16. Now, I just type it below so that I get some space. Now I shift it once more, so it becomes 3, 2, 1. So in that case, this is not there because this is 0. 3 into 3, 9 plus 4 into 2, that is 9 plus 8, that is 17. And then once more shift 3, 2, 1. So no other terms, only 3, that is this is y3 and y4 is equal to only one term, 4 into 3, that is 12. So 12. So the answer of y is answer of y is 2, 7, 16, 17, 12. Y is 2, 7, 16, 17 and 12. So if there are 3 points in one sequence, 3 in other sequence, the number of points in convolved sequence are 3 plus 3 minus 1, that is 5. So in general, if I have one m point sequence, other n point sequence, the sum of convolved sequence, the number of points in convolved sequence are m plus n minus 1. M plus n minus 1. So this is convolution where the output is I again repeat because this is the crux of this entire subject. An input sequence is coming, output sequence generated by the system is convolution of input sequence with system sequence. I again repeat, convolution of input sequence with system sequence. What is system sequence? System sequence is the sequence which is there for a given system. That what that system sequence tells? System sequence tells the contribution or proportion of the input received k samples ago in determining the current output, in the proportion with which the input received k samples ago is contributing in current output. So what is sequence HN123 means? Sequence H123 means the current input is taken with weight 1, previous input sample is taken with weight 2, and previous to previous input sample is taken with weight 3. Current is taken with weight 1, previous is taken with weight 2, previous to previous is taken with weight 3. This is the, so system sequence is nothing but the weights of the inputs received k samples ago. I hope the idea is somewhat clear. So based on, if you know the system sequence, if you know the input sequence, you can find output sequence. Is it clear now? So in general, so I will try my level best to make the things quite clear and familiar to you in a common sense, with a common sense approach. What is important in any kind of what we can say elaboration is it should be understood with a common sense manner. It is very possible that you can make it highly complex things. You can make it highly complex things, but that should not be an appropriate approach. The perfect approach should be just make it quite simple. So I again repeat, an input sequence, an output sequence, and a system sequence. Input sequence, output sequence, and a system sequence. So with these three, if you know the input sequence and system sequence, you can find output sequence. Now, I would like to ask an alternate. Is it clear? So if I give you what is xn, if I give you what is hn, remember that now there should not be any jumbling between k and n. So in general it is an index. Only thing is that when two indexes come together, to differentiate between them, we have to use other index. So otherwise, input sequence, system sequence, output sequence. So if you know the input sequence, if you know the system sequence, you can find output sequence. Now my question is that suppose if I give you a circuit is given to you, so you can understand that circuit. If I apply input, if you know the circuit, I tell you the input, then based on your understanding of the circuit and knowing the input, you can compute the output, right? So if I give you a circuit, if I give you V in T, you can find V of T, circuit given. Means given circuit, given input, you can find the output. Now there is some kind of alternative ways with which the knowledge is tested. Suppose if what I do is this circuit you are having exponent chassis, you connect input, you get output. Now what I do, in the exponent chassis, this circuit which is there, I will mask. You are not able to see the components of the circuit. Input is given and you can observe the output. Is the question clear? Given the circuit, given the input, you can compute the output. Now, if I give you the circuit, I mask the circuit, you are unable to see the components. I give input terminal, output terminal. You can give the input, you can get the output. So, the question is now, based on input you can observe, output also you can observe. Earlier what was the situation? Input circuit was given to you, it was components were shown to you, how they are arranged. Input was told, so you were able to compute what output it will give. म्हणजे एखाद्या सर्किटला एखादं इनपुट दिल्यानंतर आउटपुट काय तुम्ही काढू शकता. आता काय केलंय, सर्किट दिलंय पण ते झाकून ठेवलंय. तर इनपुट द्यायचं, आउटपुट बघायचं, सर्किट काय आहे ओळखायचं. जस्ट सम काइंड ऑफ asking the problem some twisting. So if xn is given, yn is given. If xn is given, yn is given, the answer is yn is equal to summation k equal to 0 to infinity hk x of n minus k. X of n minus k. Now, system equation is hidden from you. You means there is a computer program, but the computer program is not available to you. So it's an exe file. Somebody has written some program. There's an exe file. That computer program is not available to you. You cannot check the computer program, but you can run the computer program. When exe file is there, you can run the computer program. You are unable to check, but you can run it. So you can give input, you can observe output. Then what I want, if xn is given, xn is means you are at liberty. You can choose xn. You can observe means you know xn, you know yn. So you know xn, you know yn. Compute hk. So from input sequence and system sequence, we were computing output sequence. Now the task is input sequence is told to you, output sequence is told to you. Based on these two, you have to find system sequence. Or you can choose an input sequence. You can choose an input sequence. You can observe output sequence. You should tell what is system sequence. अच्छा झालं का? HK दिला, input दिलं. म्हणजे सिस्टम सिक्वेन्स माहित आहे, इनपुट सिक्वेन्स माहित आहे, आउटपुट सिक्वेन्स काढता येतो. आता सिस्टम सिक्वेन्स माहित नाही आहे, तुम्ही इनपुट सिक्वेन्स तुम्हाला हवा तो देऊ शकता, आउटपुट ऑब्झर्व करू शकता. यू शुड बी एबल टू टेल व्हॉट इज द सिस्टम सिक्वेन्स. यू कॅन चूज एनी इनपुट विच इज कन्व्हिनियंट टू यू, थिंक समथिंग अँड टेल मी व्हॉट इज HK. You can take a break and immediately those who have finished can verify, those who have not finished can watch. We'll continue immediately after some time. Thank you.